And now, so we're drawing the ball here, and we'd like to make it a circle instead of a rect. Well, instead of calling the rect function, let's say canvas context fill style. Let's keep it red for now so we can make sure we're looking at the same shape. Canvas context begin path. That begin path is going to let us define a shape to then fill in. Canvas context dot arc. There is no circle function in HTML5 JavaScript, just an arc. We're going to draw it a ball X, and let's say 100, 10, 0, math, pi times 2, true, and there's still a line left to make a circle happen. I'll explain in a second what's going on here because, right, that's pretty awful looking. Oh, math pi. Pi's got to be capital. Okay. So now we have this ball that's bouncing. Let's walk through what this is doing down here. Fill style, you know what that is. You recognize that from the rectangle code. Begin path is important because the way that we're going to fill this in is by calling fill at the end. There's no arc fill in the same way there's a rect fill. An arc is really meant for drawing like a sort of a filled in chord of a circle in which it accepts a few different arguments. The first two are the X and the Y position, just like we had for the corner of the rectangle, except here instead of being the corner of the rectangle, it's the center of that circle. We then have the radius of the circle is the third argument. So here by saying it's 10 pixels, the circle is going to be 20 pixels wide and 20 pixels tall. And the next two are the angles and radians around the circle that we want to make for our section of sort of like pizza, if you will. And if you've never seen radians before, this can look kind of confusing. We're going to bury this into a function to draw our circles for us, so we don't have to worry about it in the future. But the way this works is that instead of dividing a circle into 360 units as degrees, which we're used to like 90 degrees as the right angle, radians instead asks how many times can I take the radius of a circle and lay it along the outside of it. And it turns out that 2 times pi is the number of times the radius fits around the circumference, which of course is also how you get like the circumference formula for a circle. If you've never seen radians, don't sweat it too much, except to say math pi is half of a circle. So if I save this, there's only the top half of the circle. I'm going to increase its size considerably so it's easier to see to 100. There you can see we have 100 radius circle, half drawn. And now this is only pi instead of pi times 2. Or we could say like pi divided by 2. We'll get a weirdly busted 3/4 shape. Notice that it's not drawing like slices of a pizza. It's drawing like the full arc and then connecting it at the end. This right here, this true or false, has to do with whether it's going clockwise or counterclockwise from that angle. If I change it to false, now we see the other section we see the 90-degree corner instead of the 270-degree around minus that corner. Or if we just did half of a circle, false would draw the bottom half of the circle, true would draw the top half. Now, I'm kind of showing you all this because I want those parameters to be demystified. I also want you to be comfortable just filling in those kind of numbers and just playing with it and just seeing what comes out of it. But we don't actually have to think too much about that because we're going to answer that question once. We know that math works out for 0 to math pi times 2. Math pi is just a built-in constant for 3.1415, yada yada. Why does a circle with 100 radius drawn at a vertical position of 100 skim along the top? Remember, the radius is a distance from the center of the circle, and so this ensures that we're surfing that edge. If the numbers are the same, if we make them both 50, it'll rub along the edge at half the size. So something to think about. But let's make the ball 10 tall. We have a ball. Let's also make it white. While we're at it, we want to eventually make the ball white anyhow. And there we go. We have a circle. Now, if we look at this code later, it's not going to be clear that it needs to get grouped together. It's not going to be obvious what it's doing or why. Just like we wrapped up the rectangle function into its own separate helper function is what I call these things. It's a pretty common term for them. Let's do a similar thing for the circle to hide this ugliness of how a circle gets drawn. Function, color circle. Because, for example, these extra parameters here about these two, in fact, all three of these, whether or not go clockwise or counterclockwise, which angles to draw the circle between, we always want that same answer if what we want is a circle. All we really care about is the horizontal center position, the vertical center position, and the radius. Those three numbers. So that's the only ones we're going to ask for. We're going to ask for let's say center X, center Y, radius. We're not going to ask for the other ones because I'm going to cut this code. We will ask for the color though, just like we did for the rectangle. And I'm going to replace ball X here with center X, which just gets its labels. Oop. Getting some unwanted parentheses here. Center Y will be the second number there. Replace a 50. And these are again called arguments or parameters. Radius is the next one I want to get my hands on. We can call these anything we want. So even though these, once again, as always, these labels, even though they are meaningful to us as human programmers looking at words like radius and center X and center Y, the computer actually doesn't really care where we stick those as long as they are numbers. And then draw color, I'll stick in here in place of where it defined white. Now for drawing the ball, I can just have a single line that says at ball X, position maybe 150Y, make a white circle. We didn't give it our radius. Radius of 10. What's nice is that now that we've figured out here's how to draw a circle, we don't ever have to look inside this function again. We don't have to worry about it. We also didn't have any reason to replace this 0 math pi times 2 or true with parameters because we don't want to change those when we draw a circle. We always know what those are going to be when we draw a circle. So we've made a helper function now for drawing a circle as well. Makes that a little bit cleaner and easier to deal with. Let's go ahead and get this ball to now bounce vertically as well. We're going to do it in the next video.